timer start automatically?
When it stops flashing, it has technically started. If you want to start over, just press that again.
Okay. Thank you, Dr. Newman. I'm excited to share a little bit of the research that we're doing at the University of Kentucky in the Department of Animal Sciences. You've probably heard a little bit today about the bad parts of fescue, tall fescue, and I'll just say get ready to hear a little bit more. To start off, ergot alkaloids that are present in endophyte-infected tall fescue have been shown to induce vasoconstriction of peripheral vasculature. We've seen this both in the animal in vivo experiments and in the lab in vitro. We've recently also shown in vitro that ruminal vessels are affected by these same ergot alkaloids, and mainly ergovaline is the main causative agent, we think, for the animal symptoms. We also know that nutrient absorption from the rumen or the foregut of the cow is dependent on blood flow to the absorptive surface or the epithelium. Therefore, we think that the ergot alkaloids could decrease nutrient absorption from the rumen, and this could contribute to the symptoms of the fescue toxicosis syndrome. The objective here was to evaluate rumen epithelial blood flow and volatile fatty acid absorption from the washed rumen of steers fed either endophyte-infected or endophyte-free seed in the presence of differing levels of ergot alkaloids. To do this, we used 8 ruminally cannulated steers that were paired by weight. One steer from each pair was assigned to the E+, or the endophyte-infected seed treatment. The other steer received the E-, the endophyte-free seed treatment. They received the seed through the rumen cannula twice daily. Steers were pair-fed based on the intake of the E+ steers, so that when their intake went down, we reduced the E- intake as well. We offered alfalfa cubes at 1.5 times their maintenance requirement. As I said, seed was dosed twice daily for 7 days at a previously determined rate of ergovaline. We then performed a washed rumen experiment on day 8. And this was done both at thermoneutral at a nice comfortable 70 degrees and also at heat stress conditions at a warm 90 degrees. The steers were then crossed over on their seed treatment and the experiment was repeated. As I said, after 7 days of feeding the seed and equilibrating to the ambient temperature, we performed a washed rumen experiment. This began at 7 a.m. by weighing the steers and placing a jugular catheter. We then collected a serum sample for prolactin analysis and a plasma sample for background deuterium oxide or heavy water. We then moved the steers to individual pens and removed the rumen contents, and we stored those in a hot water bath or a forced draft oven. The rumen was then rinsed with warm tap water followed by 3 rounds of saline rinses. We then incubated a series of 3 buffers in the rumen. The treatments included a control, which just had the excipient or the vehicle. Then we had a 1X, which was a daily dose of ergovaline, and a 3X, which was 3 times the daily dose of ergovaline. It is important to note that the ergovaline for the washed rumen buffers was provided as an extract of Kentucky 31 tall fescue seed. So there were other ergot alkaloids present than ergovaline, but we based everything on the concentration of ergovaline. Here's just a visual depiction of our buffer incubations for the washed rumen experiment. We did go control buffer followed by the 1X followed by the 3X. For each buffer treatment, there were actually 2 buffer incubations, which included an equilibration buffer and a sampling buffer. After the sampling buffer, we removed it and washed the rumen with saline and then moved on to the next treatment. We collected buffer samples at the times noted and blood samples from the jugular catheter, also at the times noted there. Here's a table showing the chemical composition of the buffer, which is just a typical Krebs buffer with the addition of volatile fatty acids, a major energy source for the cattle. The equilibration buffer, as I said, contained either the excipient or the extract. The sampling buffer was identical, except it also had chromium EDTA and deuterium oxide, which were used as markers. Some of the calculations we did, a model was developed to predict the amount of water in the rumen when we added the buffer or residual water. We also predicted ruminal liquid passage rate, which is how fast the buffer was escaping the rumen into the lower gut. And we also estimated physiological water influx, which was just saliva or water coming across the rumen wall. Data from that model were fitted against the observed chromium concentrations and the initial buffer weight. This allowed us to calculate the liquid volume at each sampling time point. And using that calculated volume and our measured concentration of metabolites, we were able to calculate a pool size, or the amount of the metabolite that was present at each time point, and we could look at the decrease over time. We also corrected that for passage out of the rumen in the liquid and influx into the rumen through physiological water. For the deuterium oxide, we went on to calculate a ruminal clearance, which was just the flux or the absorption relative to the concentration in the buffer, and corrected for the plasma concentration. The key thing here is that the ruminal clearance of deuterium oxide is our measure of blood flow to the rumen epithelium, to the absorptive surface, and that's what we were really interested in for this experiment. The data for this was analyzed as a randomized complete block design split plot. The whole plots included the seed treatment and the crossover period. And the subplot was the buffer treatment, or it's easier to think of as the extract level. Thermoneutral and heat stress data were analyzed separately, and data are presented as LS means with standard error. As we move on to the results, we can take a look at feed intake on the y-axis. This is just simply a fraction of the net energy of maintenance requirement. And it's broken out from day 1 to day 7, and at thermoneutral and at heat stress. We saw a temperature by day interaction, which indicated that at heat stress intake was severely depressed, but at thermoneutral there was no effect of the seed treatment on feed intake. So we look at prolactin. This is at thermoneutral. On the y-axis is just the concentration. We had a seed treatment effect, which showed that the E+ steers had lower prolactin concentrations at both day 0 and day 8, but the difference was much more pronounced at day 8. At heat stress, it was slightly different. We saw a day effect, where both groups of steers had lower prolactin concentrations at day 8 than at day 0. Moving on to the epithelial blood flow, again on the y-axis it's just blood flow to the absorptive surface, liters per hour, and it's broken out by seed treatment. If we'll take a look at the extract level 0, which is just the control buffer, we see that the E+ steers had about a 30% lower epithelial blood flow than the E- steers. And this is due solely to the seed treatment. Now when we added the extract into the buffer, we increased the concentration of the ergot alkaloids present there. We saw a large decrease in blood flow to the absorptive surface at both the 1X and the 3X, and in both groups of steers. And this is at thermoneutral. At heat stress, the data got a little fuzzier, but there was still a trend here for the E+ steers to be slightly lower than the E- steers during that control buffer incubation, and adding the extract in did cause a pretty severe reduction in epithelial blood flow. The nice thing with this model is we were also able to calculate and to measure the absorption of acetate, and this is at thermoneutral. This is just millimoles of acetate per hour. The interesting thing here, I believe, is that with the control buffer, there was no difference between the E+ and E- steers, but there was a 30% difference in blood flow. So somehow these E+ steers are able to absorb more acetate per unit of blood flow. When we added the extract, we saw a pretty large decrease in acetate absorption for both the E+ and E- steers. although there was a slight tendency for a seed effect, which indicated the difference might have been a little more pronounced for the E+ steers at thermoneutral. At heat stress, we saw the same basic trends for acetate absorption, where the extract had a large effect on acetate absorption. I didn't take the time didn't allow to show the other volatile fatty acids. We did measure it. They all kind of followed the same trend as what you saw for acetate. So to summarize, feeding the E+ tall fescue seed caused a large decrease in feed intake at heat stress. It also decreased rumen epithelial blood flow at thermoneutral, as seen in the control buffer, but there was no effect due simply to the seed on VFA absorption, which we think could indicate a difference in epithelial VFA metabolism. When we incubated the ergot alkaloids, or the extract in the washed rumen, we saw a decrease in epithelial blood flow and a decrease in VFA absorption. To our knowledge, this is the first demonstration that toxic tall fescue reduces both blood flow and nutrient absorption at the gut level. And it seems pretty clear that gut blood flow alterations can contribute to the fescue toxicosis syndrome. And with that, I'll take any questions that you might have.
Questions for breeds of cattle?
The question was what breeds of cattle we use. These were Holstein steers that were much easier to cannulate and handle.
I have a question. What are some practical implications of your work?
The question is, what are some of the practical implications of our work? The way I kind of think of it is it's just more demonstration that blood flow is the problem and the vasoconstrictive action of these alkaloids are the problem, and that perhaps we need to focus our research more on fixing that. And it just gives us more evidence of the mechanism of the disease to give us direction to fix it.
How much effect do you think we have by washing the rumen and changing microbial population might have affected the levels of impact it has on the ecovariance on the blood flow?
I'm not sure I understand.
You wash the rumen of the cannulated steer.
Yes, sir.
You're removing a lot of microbial population. How do you think that changing that microbial population affects your results?
When we incubated the buffer, we removed the majority of it. There should be very little microbes present. We washed it pretty thoroughly. We can't remove it all. So that's one of the reasons we use the extract, so that in theory, the ergot alkaloids would be in solution and be available for absorption. That's obviously not the case when they're cattle grazing, and digestibility is a major factor, as well as microbial metabolism of ergovaline to the other less toxic alkaloids. So it's not a perfect model for the grazing. Yes, sir.
Yes, did you say whether the seed was ground or fed whole?
It was ground.
And would that have made a difference, do you think?
I think so. One of the reasons we grind the seed is that we can't really feed it, palatability issues, and we can really control how much we are giving to the animals by feeding it or giving it through the rumen cannula. So grinding will have an issue on the availability of the alkaloids out of the seed, I believe.
Thank you. Thank you very much.